Hey there, we are starting the section on trigonometry. There are matching videos. You know what, while you guys do that, I'm gonna send you the link so that everybody has the videos for this whole section because it's cool. Or did I already do that this morning?
I just got the Zoom email.
It just seemed like it was a weird place that the computer was waiting for me. So I'm sending it now. Well.
$39 for the first one.
89?
$39.
Oh, 39. Because I was like, no, that's not it. Okay, I will check. There we go. So this is a really good one. Both of these are for, you let the equation guide your thinking. So once you have the equation figured out, and I mean, it's the only thing we have for right angle triangles right now, you just make sure you plug the stuff in the right spot. So 1764, 256, yes. So whether you have the two sides or a side and a hypotenuse, those first three steps don't change. You just got to watch where you put your numbers. It's just this time, you need to subtract. So 1764 minus 1508. Good job, Tristan. So 39 looks good.
The second one doesn't make sense. It's 16.
Yeah, no. Nope. That one I can say you're wrong.
What?
It can't be. That side is the hypotenuse.
I know.
Okay. If you
What
know
am I
that,
wrong?
it's got to be the longest side. So 16 is not it. Sammy, how you doing?
I went 15 squared plus 17 squared.
Mm-hmm.
I'll get it.
Okay. Hold on. Let's wait for Sammy. You figure out what your error is.
I'm trying.
I know, because you can do this. I have faith in you. I might even have written the two of you up in a good way in my month-end report.
Yeah.
It's my students who keep showing up.
So the first one, I change because the 8 is higher than 5, do I go to 39 then?
Yes.
Because I got the same thing, 38.8. Okay.
Oh, no, that's not right. What the
All right. So
Oh, I see what I did wrong.
What'd you do wrong?
Just entered in the calculator wrong.
Oh,
Yeah.
so your math is fine. Just your ability to use a calculator is a little off?
Yep.
Oh, sorry. I just realized that's recorded. I'm sorry, Tristan.
That's fine.
I thought you could. You seem like
I
a
was
guy who could
thinking
handle
it.
You seem like a person that could handle that.
.23.
And that's the thing about making sure you take a look. Is it the longest side? Because if you didn't know that, you would have said, oh, look, I got the question done. Aren't I clever?
Well, that's why I was like, what the hell?
Yeah. There's not, I don't think there's any way that I can screw up the question so that they won't work in Pythagorean's theorem, as long as I make sure that this is your hypotenuse is the longer one. So they should always work. However, there's some shortcomings to Pythagorean's theorem. What do we have to have?
Two sides and a right angle triangle.
All right, so first of all, has to be a right angle triangle. If it's not, you can't use it. So whether you want, just to make everything perfect, when you say either two sides or a side and hypotenuse, you have to have 2 out of 3. If you have, but it does absolutely nothing if I want to know what the angles are. And if I have an angle and a side, I can't use Pythagorean's theorem. Excuse me. So Pythagorean's theorem falls apart because of the angles. Oh, Tristan disappeared, so some of you can keep writing and get got up. It all works.
Is that an L and a D?
Oh,
Or is that supposed to be a square?
that's an angle and a triangle.
Oh, a triangle. Okay.
Oh, you also get used to my boring, weird shorthand. All right, so today we are going to start learning about what are called trigonometric ratios. There are 3 of them that we have to care about. There's actually 6, but unless you're in pre-calculus, who cares about the other 3? And it's going to allow us to figure out angles. Or if you have an angle in a side, it'll allow you to calculate whatever you're missing. It's pretty cool stuff. Before we get started though, I'm just gonna fess up. I have a terrible sense of direction. I've gotten lost so many times in my life, it's embarrassing. I was once, and I'm not kidding about this, I was scuba diving and I was going in one direction and I was so proud of myself and I was checking out the coral reef, and within like 2 minutes, I ran into my diving group again because I wasn't going in one direction. I had gone and turned 180 degrees and I was back towards the people, thank goodness. No sense of direction. So growing up on the farm, my dad and I fought all the time because he's like, go north, 2 miles. And I'm like, which way's that? Then he'd say left. And then, of course, I can't do left and right. So I was lost all the time.
I do that too. Oh yeah.
But if
Right.
you want to give good directions, oh, I will add one more. When I first moved to Regina with my husband, I was telling him about going to the Northgate Mall. You know, the one in the south end of town. And he said, what did you say? And I'm like, oh yeah, I guess that's why it's the Northgate and the Southgate. There's a point to this. If I tell you to go north, no matter which way you're facing, this works better if we're in class. Let's see, in the classroom, I have to think now. Now I'm lost. That way is north. Because it's towards the door and it's towards Northgate Mall. Now, if I turn around, check this out. That's still north. That's not very exciting. But if I tell you to go left, that's that way. Unless I'm turned around, that's that way. So it's really screwy. Getting back to our lesson.
Yeah, my brothers used to bother me about that all the time. Like we used to play chicken, like riding bikes and stuff, and we'll be like going like towards each other, and they'll be like, oh, "Okay, I'm going left," and it's like, "Well, is it my left or your left?" And then now we're both screwed. It's like, "Oh shit, which way are we going then?" And sometimes it ended in a big crash and broken bones.
Camera left and camera right.
Yeah, and everything's reversed on the camera, so I'm just completely screwed. So let's draw ourselves a lovely triangle. The nice part is the hypotenuse is like north, except you always know which direction is north because it's a hypotenuse. So this part is always, always, always the hypotenuse. And if I turn my picture, whatever I want, it doesn't matter, it's still a hypotenuse. Hey, that's cool. I can't do that with a whiteboard.
No, you can't.
Okay. Always. Now, we're going to start talking about the angles. And I'm going to give you a new cool symbol. So that thing, think about that because somebody just knocked on my door, is called a theta. And I don't
Looks like
even
an
have-
Easter egg.
It looks like an Easter egg with a line through it. Gonna find the grass. All right, sorry about that. Okay, anyway, so yeah, it looks like that. And it is pronounced theta. And you know, when we do regular algebra, it's always like x plus 3 equal, don't write this part, or 5x equals 16. For some reason, mathematicians decided that x is what we're going to use for unknown. Well, in geometry, they don't use x. Most of the time, they use theta. And theta usually represents an angle.
Like a missing angle?
Yep. And as I wrote, usually I'm thinking, I don't know if it's ever used for anything else. Either a missing angle or the angle we care about. So if you travel down, see these two, sorry, are going to get upgraded. They're no longer going to be just sides. They're going to become the adjacent side and the opposite side. And either it's going to make complete sense or you'll follow my rule. Either way is going to be good. So my rule is I start on my hypotenuse. I pretend I'm like a little ant and I go around the corner where the angle is, and that makes this side the adjacent. Because adjacent means like beside. So this line is beside the angle. So it's the adjacent. If you keep going around one more corner, this becomes the opposite side. And I'm just going to be honest, some students can completely handle that that's the side opposite the angle. Other people, not so much. So my rule is to go around the corner, and there's my adjacent one. Now here's where it gets fun. Draw yourself the same triangle again. Except this time, we're going to put the theta up there, up in the top corner.
So you're just going to be going around the other way?
First, we label the hypotenuse. See, it's like north. It's always the same. But now we go this way. So then what's this side called?
Adjacent.
It changes. My writing got bad there. And this becomes the opposite. All right, Julio. You guys don't even have to write these. I just want to make sure you are all together. All right, Tristan, you're up. Where is first triangle? Which one, side 1, 2, or 3, is the hypotenuse?
2.
Nice.
1's adjacent, 3's opposite.
Okay, my work here is done. All right, Sammy.
2 will be the hypotenuse.
Hypotenuse. Okay. Which is the adjacent?
3.
Yep, you go around the corner.
And then 1 will be opposite.
Nice. You guys are rocking this. All right. Which one is the hypotenuse on the last one? Either of you?
1.
No.
3.
No.
It's
Done.
equilateral. There is no hypotenuse.
Boom. Gotta be 90-degree first. All right. Don't be asking me if I'm Cree unless I'm First Nation first, right? Unless it's a right triangle, you can't use that word. So, psych job. Trick question. Okay. If we were in class together, I could go through this really long explanation about this next stuff, but you know what? We're not. And it's the end of the semester. Oh, and I should say that this is an entire, at least month in grade 12. So this stuff's really important. So I'm not going to give you the long lecture. I'm going to give you the easy one, and we're going to make life work. There's 3 trig ratios. Okay, a ratio, you remember from before, is comparison of things with the same units. And these are called the 3 primary trig ratios. Trigonometric, but I'm too lazy to write that. Oh, good, and I recorded that. My bad. Okay, so we got sine theta, cosine theta, and tangent theta. So the ratios are called sine, cosine, and tangent.
So all these things are gonna pop up in grade 12 math?
Oh yeah.
Okay.
So in grade 10, we apply these three ratios to right angle triangles. In grade 12, we do that again. So whatever you learn here, you're going to have to do again. But then we apply it to triangles that aren't 90 degrees, which is pretty cool. There's some pretty cool laws.
Okay.
And one of them, actually, I'll show it to you. This is called the cosine law. Don't write it. Oh, it got all messy there. C squared is equal to A squared plus B squared minus 2AB cos C. That's what we're going to work it. But basically, this part is pretty much Pythagorean's theorem again. And then there's just this cool little thing on the end that adjusts it because it's not a 90-degree triangle anymore. Anyway, maybe you have spent your entire life, or maybe you've never thought of this, wondering, why is there a sin button on my calculator?
Because it's a sin?
Yeah, I know. It's like, if I press that, am I going to hell? Sorry, that's right. In a church, okay? Or tan. And why is there a lot? We're not getting into logarithms, but no, there's weird stuff on here. Well, it's not a sin button, it's a sign button. And if we're in class, I will gently correct you or mock you, maybe. If you ever say sin, it's sine. So sine theta, and here comes our ratio, is opposite over hypotenuse. Yeah, you just got to memorize it. And cosine theta is adjacent over hypotenuse. And it's cos, not cos, or anything else. This is not my cos that lives in Yorkton, no, cos. And last one is tan, which no one seems to mispronounce. Opposite over adjacent. Now, back in my day, in that hotbed of intellectual brilliance of Yorkton, my teacher just said, memorize it. That's it. You just memorize those. And I'm like, okay. And then I met, I don't know who told me, but there's this thing called SOHCAHTOA, which helps everybody remember how these work. So sine is opposite over hypotenuse. So cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. SOHCAHTOA. It's pretty cool. I thought this was some new invention, but it turns out I talked to a friend of mine who's about 10 years old. She goes, yeah, we did that. What's wrong with you guys? I'm like, I'm from Yorkton. We can make pierogies, not so much on the trig. I don't know. Okay, so I think I'm just going to show you how this works because it's getting pretty out there right now. So let's take an angle, a triangle. Oh, hey, let's do this. We are going to do some thinking and predict an answer. And then we'll see if the delightful trig functions are going to give us the same one. So we got a triangle. It's right angle triangle. Two sides are 10 and 10. What can you tell me? Okay, the sides are 10 and 10, so the sides are equal. What can you tell me about the angles here and here? Are they going to be the same or different?
The same?
Maybe the same. Do you think you could figure out the measure, how much that would be?
Yeah.
Oh, I think we're missing something. We're missing something. The sum, this angle and this angle and this angle has to be 180. We'll do that lab tomorrow. So sum of angles in a triangle, that's drawn shorthand, is 180 degrees. So if I have 180 degrees, how much did I use up here?
90.
90. So when we subtract that, we're left with 90. And that 90 has to be split here.
45 and 45.
Yes. Divide by 2. It's 45 degrees. Now let's see if we can make that work. So we know our angles. Now we know two sides. Oh, before we do that, what should we label? Starts with an H.
Hypotenuse.
Yes, let's label hypotenuse. And I'm going to label this one down here theta. You know what? That's a terrible picture. Hold on. All right, so this is my hypotenuse. I go around my corner. That's my adjacent. And that's going to be my opposite. We have numbers. Opposite and adjacent. So which one of these three has opposite and adjacent in it?
And
All right. This is what we have. So this is the one we're going to use. We can't use sine or cosine because they require you to know the length of the hypotenuse. And we don't know it. And we don't need to calculate it if we don't have to. So tan theta, opposite over adjacent. Just like when I do Pythagorean theorem, I always start out with the formula. All right, so tan theta, because we're looking for theta, we should know the length of the opposite side. Sammy, how long is the opposite side?
10 feet.
Nah, we just know 10.
Okay.
Just 10. How long
10.
is the adjacent? 10. Yeah, okay, it's not very exciting. So tan theta is equal to?
1.
Yep. That's not the answer we're expecting. Well, this is the ratio of the two sides. To get the actual angle, I'll show you on my calculator. Oh, this is going to be cool. Your calculator may or may not work. And I'll show you how to fix it. We need to go shift, tangent, 1. And I get 45 degrees.
I got that too.
Nice. Kristen, how about you?
Yeah, I got 45.
Nice. Because you probably can't see. Maybe. There's a teeny tiny, yeah, nope, can't see it.
Mine's and 1.
It probably has a D there for degrees, but you can also measure triangle or angles in things called radians. I think there's another one called gradients. I don't even know what that one's for. But we always got to make sure our calculator is set in degrees. But I am going to stop because I don't want to get too far into this because, you know, your classmates are kind of missing. So that's enough for math.
What does drag mean on the calculator? DRG.
Probably degrees. So don't, as you say, if your calculator's working out, leave it alone.
Okay.
Set in degrees.
And then I have one that says DMS. What does DMS PMs?
I think it's degrees, minutes, and seconds. So
Oh.
instead of having 42 degrees, you could have 42 degrees, 12 minutes. It splits it up.
Okay, just don't touch anything else?
Yeah.
Okay.
These ones probably don't matter. It's just if you accidentally get out of degrees, then bad things happen. Your
Okay.
answers get all weird. All right, sweet. Time for science. And I'd like to tell you that there's a science booklet waiting for you, but there's not. We're going to get into genetics, which is very cool.
Are we still doing our points?
Oh, yeah. Hey, now's a good time. Oh, hold on. I'm going to stop the share so that at least it's.
Kristen, just kidding.
No, it was coming anyway.